Hi everyone, my name is Jonas Helfer, and in today's video I'm going to walk you through creating a GraphQL server for Node.js, and I'll also be showing you how to connect that to your database. In this example we'll use two databases, SQL and Mongo, and I'll also show you how it could interact with an existing REST API that you have. If you're not familiar with GraphQL, here's a bit of sort of history. GraphQL was invented at Facebook in about 2012 by their mobile team. And the problem they were trying to solve is really that with current REST APIs, you might be making a lot of round trips to fetch your data, and that's really bad on mobile because it uses your bandwidth and it is really slow. And so, GraphQL is really sort of the next generation of APIs, if you ask me. And the way it works with GraphQL is that instead of making many separate requests to all the endpoints that you have in a RESTful API, which you need, for example, to piece together your whole page, in GraphQL you can put all of that in one request. What we see people do a lot with RESTful APIs to sort of mimic that kind of or to just have one round trip to fetch an entire page is that we'll see REST APIs that have lots of custom endpoints. But then you get everything in one round trip, but you actually have a very high maintenance burden for that particular endpoint. And if anything changes ever, then you need to update your apps and you'll have many different versions of APIs and so on and so forth. And GraphQL really solves that by providing a query language that sort of sits on top of your backends, so that sits on top of your database, for example, your SQL database, or it can sit on top of your microservices, and it basically serves as the gateway that then pieces together the bits of data from the different backends to respond to one request from the client in just one response. All right, so let's try and get started here. I'm going to be using a little package that I wrote called GraphQL Tools for making this GraphQL server. And it's a package that just makes it a little bit easier, a little bit nicer, and helps you get off the ground faster. The first step is to actually install some boilerplate. And I have this one on GitHub. And if you want to follow along, I think that should all work. All you're going to need is a text editor. You'll need Git for cloning the Git repo, and you'll probably need a MongoDB running on your computer if you want to do that part of the tutorial. And I think that's pretty much it, apart, of course, from having Node and NPM. But I guess if you're watching a Node tutorial, then I guess I can kind of take that for granted. Okay, so let's clone the boilerplate, and I'll explain in a minute what's in that boilerplate directory. We'll go over everything. And we'll clone only the server branch, because in this tutorial we're not going to need the client stuff. So let's go to that, and I'm going to open my text editor here, and we have it here now. And I'm also going to npm install things, because we all know that can be kind of slow sometimes, so I'm going to be doing this in the background. So this boilerplate actually doesn't contain very much. I'm going to go through all the files very quickly. It only has two dependencies. That's Express and the GraphQL tools, which I mentioned earlier. And everything else is dev dependencies, so Babel for transpiling JavaScript to be able to use some ES6 and ES7 features, and then ESLint to show me where I made mistakes before I actually run the thing. And NodeMon is just basically a Node or Babel node wrapper in this case that will restart the server when any files change So that's up here. So we're just going to run npm start when we start the thing. So that's package.json. You'll see npm start will start the server.js. So in server.js, we're just building a very basic Express server. So I have all these imports. We have to import Express. And we'll also import Apollo server from GraphQL tools. And GraphQL tools has a lot of small functions that help you do individual steps, but Apollo server really just ties them all together. So most of the tools you can use, even if you have an existing GraphQL server, existing GraphQL JS schema, most of the tools you can just use with GraphQL JS directly. Apollo server is just sort of a nice wrapper that helps you put everything together very quickly. Then we'll import a schema. We'll look at that in just a bit. So every GraphQL server has a schema. That's sort of what's at the core of the GraphQL server. And it's also what makes it so powerful, because the schema has strong types, which means making documentation for your API, something which is really hard to do in REST APIs. And it's especially hard to keep up to date. And sometimes documentation is not so useful. In GraphQL, that's really easy because the schema defines exactly what queries you can send to your server and what responses you can get back. And so you can build some kind of tool. So you can build some tools on top of that. And we'll show you one of those, graphical, in just a minute. Mocks, we'll get into that later. That's basically just to fake data when you don't actually have your backends connected yet. So here we just define the Express server, and we'll tell it to use Apollo server as a middleware, and they'll be serving on the root of the server. And we pass it 4 arguments. The first one is graphical, which is that GUI that I mentioned before, which helps you inspect the schema and helps you query the server and get responses. Next one is just for pretty printing. I don't think we're actually going to need that. And then what you have to pass it, what you always have to pass it, so the first 2 here, they were optional. You always have to pass it a schema. So we'll look at the schema file in a second. And here in this case, we're also passing it some mocks. And then we just tell the server to listen on port 8080, and we're printing the console once it's ready. So let's take a quick look at the schema here that we defined. So this is GraphQL schema language here. In case you didn't notice, this here is a string. And then inside that string, we're basically defining the schema. And we're telling it what types, or we're telling the GraphQL server what types exist in that schema and how they relate to each other. And so the very basic boilerplate, the minimum that you need is you need to have a schema that defines a query. And the query here is a type that can have different fields. And your actual queries that you're going to be running against the server will be the fields of this query. And in this case here, we only have a single field. So the only possible query will be test string, and that will return a string. So we export that here as an array of type definitions. So we can import it in the server and just pass it to Apollo server here. And the last file we're going to look at is mocks, which is going to create some mock data because we don't actually have a backend yet. And so what this file here defines is what the server is going to return, or what our schema is actually going to produce when it gets a query. And so here, this mocks file is very simple, and it just says, if anyone asked for something of type string, which we saw before that test string was something that would return a type string, then it's just going to run this function which returns it works. So if we run a query for just test string, we should get it works back. So let's go ahead and actually run that. I think it installed everything, so that should work. So we're just going to run npm start and see it should be running on localhost 8080. So I'm going to switch to the browser here, and I'm going to open that here. And what you see here is the graphical, the GUI for GraphQL basically, which is also was built by Facebook. And here on the left side, you would enter a query, then you click run here, and you should get the result on the right side. And you can also open documentation here, which is like a really nice API explorer. So you notice we wrote very little code, but our API is actually already documented. It says root types for query is query and test string is string. And so we actually already know what queries we can run against the server, and we know that we should expect back a string if we run the test string query. So let's actually write that query very quickly. And you'll notice GraphQL or graphical, because it knows the schema, and it can also tell you when you made mistakes. So this is how you write a query. See, it's already suggesting that I write test string because it knows that this is the only thing that's available. So let's write that and then run it. And what we get back is data and test string. It works. So it looks like everything is working really well. All right. So now that we have our test server working and we know it's all good, it's all wired up correctly, we can start actually writing our schema. So in order to write the schema, we're just going to modify this file. And in this tutorial, I'm going to be building a small blog which has authors, it has posts, and it has views. And then in the end, to demo the REST API, I'm going to add a little thing to that that's not really connected, but I couldn't come up with anything better, so that's what we'll use. It'll be fortune cookies, so that's what we'll use to show how you can interact with a REST endpoint in GraphQL. All right, so we'll still need the type query, but we're actually going to replace the test string thing. But first, let's actually write our types here that the blog is going to have. So we're going to have a type author, which we just write like this. So we define a new type, and we say an author has a first name, which is of type string, and it has a last name, which is also of type string. And then the author will have a couple of posts. So there will be posts, and posts will be an array of type post. And you notice we haven't defined post yet, but we'll get to it right away. So we'll do type post, and we'll say a post has a title, which is a string. It will have some text. Oops, text. Typing is hard. Which is also of type string. And every post will have an author. And so that refers back to the type author. And now here for query, now of course we don't want to query test string anymore because that's not very interesting. So we're gonna make it such that you can query for an author and pass some arguments, and what you'll get back is a thing of type author. And so let's allow querying by first name and last name. Now these don't have to match up with the ones up here. You can pass any arguments. You'll see later how those arguments are actually used to then find an author in a resolve function. We'll get to that in a bit. So thanks to the mocking thing that we have going on here in the server where we define mocks, we actually already have everything that we need to test that server and see if it runs our new query. So let's look at the schema. So we have type post, we have type author, and we have type query. And because we have a mock server, we should actually be able to run that. Now I'm just going to reload it so the server will learn the schema. See, now we remove test string, so the server is telling us it cannot query field test string. But what we can query is author. And we can query first name. Let's search for someone named Paul. You'll see in a second why that's going to be interesting. Well, it's not, but anyway. So here, let's try to run this query. And we're getting back, so we asked for author with name Paul, and we got back first name, it works, and last name, it works. I guess it works, but it's not exactly what we expected. Now, I'm going to spend just like a couple minutes actually improving this mocking data, and this is not something you necessarily need, so you don't need to mock your server, but it can help you test really quickly if your schema works. And on the client side, it can also be very, very useful to develop a UI when the server is actually not completely finished yet. And everything you need is really a schema. So let's go to the mocks file and actually improve the mocking of this thing here. So notice how we said it will always return a string here, or if something is of type string, it will return it works. That's not very interesting, because what we actually want to do is we want to mock an author, and we said author, we said we can search by first name and last name, and we want that to return something that's kind of useful. So we'll make that such that if someone, oh, actually this is wrong. So we call this query, I believe. And we say that if someone searches for query author, then they should get back an author that actually has the first name that is of type name there, or that kind of makes sense for a name. And so something that we're going to install for that here is a package called casual. And casual is just, it's kind of like Faker, if you know Faker. And it's going to help us like create more realistic mock data. So I'm just going to write, that crashed, of course, import npm install, and we're going to save def casual. And that should work, hopefully. Yeah, so casual is going to let us like return a little bit more realistic mock data. So let's start the server again here, and that should run just fine. Okay, let's go back here, and we're saying if, so query author should be, so this is here, this is the root value, and then here we have the arguments. And this is the thing that we really need for returning an object of type author, which should have first name args.firstname and last name args.lastname. And then we'll also say, if you do get an author here, well, okay, it's lighting up like a Christmas tree. Unexpected labeled statement. Oh yes, okay. What I actually want to do is this. I want to return an object, so this should not run as a function. Right, so this is better now. Just this here and comma. Okay, so yeah, ESLint really helps sometimes. So here for author, we're going to say, for author here, we want to return something that has, where the first name is casual.firstname, and last name is going to be casual.lastname, not surprisingly. All right. Okay, let's see if that works. Hopefully it didn't crash. All right, it didn't crash. Doesn't mean it's actually going to work, but okay, last name, it's still returning it works, but for first name, it's actually returning Paul. Okay, let me try and figure out why that's not working here. Anything of type author should return first name. All right, I'm not exactly sure why it doesn't work, but let's just ignore that for now and continue working, because we'll not actually need the mocking too much here. Or maybe we'll figure it out later. Let's also make mocks for type post. And what we want for a post here is, we want the post, we have a title, we're going to return a casual.title. And for the text, we're going to use casual.sentences. And we're just going to make that 3 sentences. And that should let us mock a post as well that looks a little bit more like a post. So, so if we run that, that should still be fine. Now here, we said post is actually a list or an author has a list of posts. So we have posts here, and we can expand that further, and we can get the title, and we can get the text of a post here. So let's run that, and yes, we do actually. I don't think this is actually a title here, but it's, oh, it is actually a title. That's the Latin words that casual returns, and this here is a bunch of sentences here. All right, so far so good. If you also search for last name here, you'll see Simon, whatever. Then you get first name Paul, last name Simon, and that person has 2 posts. So that already looks like kind of nice. And if you go back to the schema and look at what types are in here, you see that the post also has an author, which refers back to the author. So you can always like put that in here and keep going and so on and so forth. But with the mocking, it's not actually going to keep that reference. So you're actually going to get different first names and last names. Yeah, so it looks like, yeah, so those are like kind of realistic first and last names. But anyway, so remember, like all we've written so far is this schema here, and we're already able to query the server and get some data that looks pretty much like what we're going to get. If you want to learn more about that mocking and how the more sophisticated features of it, you can check down in the links in the description for the GraphQL tools package, and there's also a mock demo that is linked in the description. All right, and I actually just realized that we need to add 2 more types here, or 2 more fields to these types, which is an ID for both of them, which can be useful when we have the things in the database. And so, all right, so until now, we've just been mocking the data. So we haven't actually connected it to the database. So let's do that. And in order to do that, we're going to create a new file here. And we're going to call it resolvers.js. And resolvers.js is going to define how the GraphQL server will actually resolve these different requests. So for each field in a query, a specific resolve function is going to run, and those are the ones that we're going to define here. So let's say, okay, so we're going to need to define resolve functions as an object here, and for each type here, we're going to need a property in that object, and it's going to define, for example, how query.author is going to resolve into an author. So how to turn these arguments here into an actual author. And so here we define this is query, and here we have author. And author has, so it gets a value passed that we don't actually use, so I'm just going to put that underscore there, and then it's going to get the arguments, which is going to be first name and last name. And then it needs to return something of type author. So we're just going to like pretend that we actually have an author here. And because that's basically how it works. Yeah, okay. So what is that? It likes to have a space. Yeah. And this is never actually used, but we'll use it later. So that was for query. We also need the same for author, which is going to have a field, which you remember has the field posts if you check the schema. Author, all of these are the ID, the first name, and the last name are going to be defined on the object itself, but the posts is actually going to be defined in the post, so it refers to a post, so we need to tell it how to resolve that. You can also define resolvers for first name if you wanted to, or let's say you had a type that's called full name. Then you could define a resolve function that takes the first name and the last name and returns that. So you can totally do that. You can define resolve functions for any field. Here we just don't define these because when you don't define a resolve function, then GraphQL.js will just use the field with that name on the object that gets passed to it. And so here we just need to define posts on author, and we need to define author on post. So let's do that here. So that was called posts, and that's going to return a list. That's again, that takes the author here. And because that's going to be passed in the return value from this function here. So it takes the author, and it doesn't have any arguments, so it's going to return, it would return like author.getPosts or something, but here let's just return a list with one item, and it's going to be ID this, and title is going to be 1, 2, 3, and text is going to be good. I don't feel like typing too much today, so that's why that's so short. Again, I think it doesn't like the spaces here, and it says I'm not using this, but we'll use that later. And then on post, we're going to have to define author, which is going to take a post, and it's going to return an author object. And I'm actually just going to reuse the one from up there. So, of course, this doesn't actually connect to your database yet, but it should illustrate how these resolve functions work. Okay, yeah, so that's fine. It wants a comma here, resolvers, right, and here, new line required at end of file but not found. Okay, oops, that was supposed to be this. And we're going to export default resolvers. All right, and then we'll go to the server, and we don't use the mocks anymore because now we want to use the resolve functions. So we have resolvers, and I'm going to import them in just a second. So we don't need this anymore, but we do need resolvers. All right, let's see. Presumably this crashed in the meantime. No, it didn't. Okay, let's see if we can still run a query here. And yeah, that seems to be working. Yeah, we just happened to call our author hey you, and the post has always title 1, 2, 3 good and text good, and we get hey you back. So that kind of illustrates a little bit how the resolve functions work. They just return an object of the type that you need, and then it gets passed from this resolve function to the next one. So whenever you have these curly braces, so for example, the author resolve function will return an author, and that will be passed to the resolve function for first name, last name, and posts. Now these we didn't have to define, but posts we had to define. So what posts get as input as the first argument is the return value of this resolve function that ran up here. And post returns a list of posts. And so these resolve functions here each get one item. So these get called once for every item in that list. And we didn't have to define these again, but we defined the author. So because we only had one post that only ran once, but this would run once for every post, and each of these resolve functions would get one of the items in that array. Okay, so now that we have that, let's try to actually hook it up to a database. And in order to do that, we're going to create a third file. So a new file, and this is going to be called connectors. And connectors is basically going to define how these resolve functions are connected to the database. So to SQL, MongoDB, or to your REST endpoint. They can really be connected to anything. So the first thing we're going to do is we're going to import Sequelize from Sequelize. And we actually need to install that first, because otherwise that's not going to work. So I'm going to stop the server here, and I'm going to do that. Sequelize. All right, so that's installed, and we can go back here, and we should be able now to define our model here. So we're going to first make a connection to the database. So I'm going to use SQLite here. We'll have to install that as well, just because that means you don't actually need to be running a SQL database on your computer. So this here is basically the username and password. So we're just passing null and null because these are not password protected. We'll tell it that we're using SQLite, and we'll call it what the file name is here. We'll tell it that. So we'll just call it ./blog.sqlite, and missing a comma here. All right, new line, okay, what is this? DB is defined but never used. Yeah, we're not worried about that yet because we're going to use it right away. So we're going to define an author model first. And so the reason we're using SQLite here actually is that this is just kind of for convenience, so we can have an ORM on top, or a higher level abstraction on top of the database. If you wanted, you could write your connectors in a way that sort of in a way that writes raw SQL queries, but using the ORM is just really more convenient because it gives you a couple of functions that you can call. For example, when you have foreign key relationships, that just make it easier to get the data out of your database and back into your database. So we're going to define an author model here. And we're going to tell it the types that we had in the schema already. So we had first name, and this is going to be of type sequelize.string. And it's going to be a last name of type sequelize.string. And we're also going to, actually that's pretty much it for the sequelize model of author already, because it also has posts, but post is actually a foreign key relationship, so we don't need to define that here. So let's go to post model, db.define post, and remember a post has a title, type sequelize.string, and let me just copy that here, and that is text is the same type, sequelize.string, and that already works. So that's all we need for that, I think. And then we're going to define, we're going to say that author model has many posts. So an author can have many posts, and each post belongs to an author. And so what that does is it tells SQLize that when you get an author object, and then you can call get posts on it, and you'll get back all the posts. And when you have a post model, you can say get author, and you actually get the author to which that post belongs. All right, so far so good. So this should already work if we add stuff in the database, but unfortunately we don't actually have anything in the database yet. So we're going to want to create some data, and for that we're going to use casual again. And that also reminds me that we didn't install SQLite yet, so I need to, so this is fine, but I need to install SQLite here. Okay, I think it's SQLite, maybe it's SQLite 3. By the way, all of the code for this tutorial is also on GitHub, so you can just find the link below in the description, and yeah, that should be fine. Hopefully it's working. Okay, so that's running. So So we had mock data before, but now if we're going to connect it to the database, it's actually not going to be very interesting to query that unless we have some data in it. So what we're going to do is we're going to create some mock data again. So we're gonna and this is basically what we're going to do here. And we want that mock data to be created every time. So we're going to tell it to force the recreation of the tables if they already exist. And this returns a promise that we then use here, and we can start creating our data. And because I want more than just one object, I'm actually also going to import lodas and use that to create like a couple of objects in our database. So we're going to run this, let's say 10 times, and it's going to run this function 10 times. And what we're going to do is we're going to create an author, and we'll just pass it the first name, which is going to be casual.firstname, as we already saw before, and last name casual.last. Okay, so that creates an author, and then we can create a post as well for that author. So we're just going to create, I don't know, one post for each author. So we're going to say title is, let's say post by, or a post by author.firstname. And then the text is going to be casual.sentences. Going to be 3 sentences here, and that should be fine. It doesn't like when I put too many spaces here. All right, now this is there. Okay, this is there. Oops, oh, I hit the wrong key. And this is the times, so I'm closing this, and this is the DB sync. Okay, I think that should already work. Oh, yeah, okay. So I haven't actually exported the connectors yet. So right now that wouldn't do anything. So I'm going to export. So I'm going to call this, I'm going to call this db.models.author. This is just for exporting. I could export these directly, but it makes it a bit clearer when I give them a clear name. So I'm going to export these. Export here, author and post. All right, so now we've exported these. So we've exported author and post, and we should be able to use that in, let me save that, and let me actually install Lodash first. Okay, npm install Lodash, because we used that just before. And so that should be fine. We're not actually using that yet, so we have to import these first. And I'm going to import them here in the resolvers and then use that there. So up here, so I'm going to do import. We're going to import author post from, this is called connectors. That I think should work. So we'll try to, it says it cannot find them. Oh, it says it's never used. Right, okay, so now instead of actually just returning fake data here, or instead of always returning the same thing and not from the database, we'll wire it up here and we'll say author.find, and we'll say where args. And now remember, args is first name or last name, or first name and last name. So if you think, so this is not actually a security issue here, because the only thing people will be able to pass in is first name and last name, and both of those have to be strings. So there's really nothing that can go wrong here. And now for posts on author, we will return author.getPosts. It's really as simple as that. And here for the post author, what we'll return is post.getAuthor. All right, let's, that post is defined but never used. Right, okay, see. Oops. Oh, okay. Yeah, I see. We're not actually using this right now. I'm gonna leave it there anyway. Maybe we'll use it later. No, actually, I don't think we're gonna use it. Let's say if you wanted to make another query where you can search for posts directly, then you would probably use the post object. But right now, we're not actually using it. Let's see if that worked. Yeah, so you can see that our server restarted and it inserted a bunch of things. So it inserted here an author called Jasmine Hartman, and so we could search for that author here. So let's search for author Jasmine. Oh, cannot read property find of undefined. Okay, author seems to be undefined then. Let me check that. Okay, let's go back here and let's look at the connectors. So we're importing author from connectors. So we're exporting them here. So we're exporting author, db.model.author. I think that should be fine. Let me just check my notes for a second here. I think that's fine. Author.find. Yeah. Yeah. Right. Okay. This is interesting. db.define author. db.define post. Let's see. Is this actually defined? We'll see in a second. Yeah, this is me debugging here. Always fun. Okay, author is undefined. So yeah, so apparently I'm not quite doing it right here. db.model, oh, it's db.models, I think. That must be it. Let's try that again. Yeah, now author is author. So let's see. Yeah, if you missed it, it's right up here. So that seems to be working now, I hope. I'm gonna save it again. It's gonna run again here, and we should be able to take a look here, and author is null. Well, that's not what I wanted. Okay. I'm gonna do one more thing, which is actually sometimes convenient. I'm gonna tell Apollo server that it should not return null. I'm going to tell it false, and I'm also going to tell it to print errors. All right, and then maybe that'll help me figure out where I made a typo. Nope, still null. Oh, I know why. Okay, so here's the problem. We were searching for Jasmine, but actually every time we're creating different mock data, luckily we can kind of fix that. So that would be pretty annoying to test if you're creating different mock data every time, and then you have to search for different authors. So let's fix that here by telling casual what seed it should use. And this is going to be used to seed the number generator. You can put anything there you want, because this is just for mock data, so it's not security sensitive here. So we'll just give it a simple seed, and it will create the same mock data every time. So now you see what did we get? So we got Edmund Jones. That's the second one here. I like Edmund, so we're going to search for Edmund here. First name Edmund. And yeah, there you see. So we get Edmund Jones, first name, last name. Posts is not quite working yet, so we'll debug that. And in order to debug that, we have to go to the resolvers. we say author.get posts. That might not be quite correct. Let me check. No, that should be right. So maybe it's not inserting into the database correctly. Let's see. So here it's inserting these, and here a post by, right. It is inserting that into the database, so I am not quite sure why it's not working here. Let me see again. So recreating this, and I'd imagine that if it's running there, so if you run this here, we're probably also printing none. So this is a promise here, which is perfectly fine, because that's what we need. So all of these things actually return promises. And and then GraphQL kind of waits for the promise to resolve and returns that. So I probably have a mistake here somewhere in my connectors here. So where I'm creating the mock data. So I said post model.create. Right, I need to actually tell it what author this post belongs to, because right now it's not. It's just creating these. It's just creating these posts without actually having a relation to the author. So what I actually have to do is tell it to use the author.create post, which SQLize will use to create the link to that author directly. And so now you see here, it actually inserts an author ID to all of these. And let's run that again. And yes, finally we do have a post, and it all seems to be working. All right, so so far so good. Now, so far we're only using a SQL database, but that would be perfectly fine. You can use GraphQL if you just have one database. But one thing that I wanted to show today is how GraphQL can be used to sort of tie together different backends. In this case, I'm going to add MongoDB to the mix. And you might wonder, why would anyone need this? Why would anyone use this ever? Why use multiple databases? It just happens that sometimes you have some legacy databases that you need to use, but you want to build other parts of your app in a new database. Or you have the case where you have different requirements for scaling things, scaling different parts of your backend in different ways. In that case, it can be really, really useful to use different databases. And GraphQL lets you do is kind of join across different databases, which is a really cool thing. And it's not just databases. It can, like I said, it can also be REST backends, which tend to be more and more common nowadays with microservices. Okay, so we're going to add something to our schema here. What we're going to add is a views field. Oh, let me save that here because I didn't save that before. We're going to add a views to posts. So we're going to say the post has a number of views. And for some reason, your manager decided that views needed to be stored in MongoDB. And so you don't really have a choice. You have to use MongoDB. But luckily now you can use GraphQL. So you can actually tie that in here. And so what we're going to do here is we're going to write the MongoDB part here. Views in MongoDB. And here, so we're going to use mongoose here for MongoDB. So I'm going to import that here at the top. And we're also going to have to install that. All right, so what we're going to do is basically, we've already defined it in the schema. So now we just need to define it in the resolve function and in the connectors here. So in the connectors, we're just going to use Mongoose here to define a new model. So first, let's make the connection. Oops, I'm going to call that this. Okay, this is going to connect to localhost, and it's going to be a database that's called views here. And if you're following along, or if you're trying to code along, then you should have already created a Mongo database called views. And we're going to declare a schema here, which is the view schema. Now, this is not to be confused with the GraphQL schema. This is the Mongoose schema here. Oops. The syntax, as you'll see, like one of the advantages of using an ORM is that the syntax of these different ORMs, even if they're using different databases, they're actually kind of similar. So here, MongoDB is a bit simpler, so we're just using actually built-in things from JavaScript, right? Number, and then we're defining the view, the actual model. So we're telling it which database that's in, and or which table that's in. So this is actually a table inside the database here, and that's actually already pretty much it. Now the only other thing we have to do is we want to create a number of views for each post. So let's go down here. So we had this create post, which was here. So we're going to do another. We're going to chain another promise here, post, and this one is going to return view. Now we could create a new view, but I want to override these every time and not create new ones. So I'm going to use an upsert, and the way you do upsert, so that's insert or update. So the way you do that in Mongoose is update, and you tell it what the sort of the key is, and in our case the key is post.id, and we want to set a certain number of views here, and casual.integer, we're going to give it something between 0 and 100, so that should be fine. And then we need to tell it to upsert. All right, so let me see, too many commas, or it's this one here. Yeah. Okay, so right, so now that's too long. Okay, fine, we'll break it this way. It's just nice not to have your code light up. Sometimes it's an actual problem, but sometimes it isn't. So I just like to generally have it such that nothing will show up, because when it's all clean, you can notice this much better if there's a problem. Okay, well, this just happens to be how Mongoose does things. So that's not something I can do. There's nothing I can do about that there. Let me see. Okay, am I not actually using Mongo? That's interesting. Okay, I think it should work anyway. Yeah, maybe Mongoose does that behind the scenes. It worked before when I did it, so let's see. Maybe it'll work again. Okay, next we're gonna actually write the resolver here for posts in post, and that's the one that is views. So that will return the views for a post, and it should return. So actually, yeah, we'll need to export that view.find1, and we're going to say post ID is the post.id, because that's the one we want to find. And now we actually have to go and export the view here in our connectors. And so let's go down here and export that as well. So let's see. All right, npm start, and this should run our code here. And it should have inserted the views as well. So let's see if that still runs. That still runs fine. And views here. Oh, okay, I didn't reload. Okay, views is null. Yeah, views is null. So this returned undefined. This is actually pretty helpful. Remember how we said that earlier? So are we actually returning that, or are we not? Oh, I didn't save the file. Okay, that explains something. I'm not sure if that's the actual reason though. Let's go back here and run that again. No, that was not the reason. Okay, so for some, so I must have made a mistake here. So this is view.find1, which I think is correct. Oh, actually, there's a slight mistake that I'm making here, which is this finds a whole views object. So I actually only want the number of views. So I think this is what I'm going to have to return here, and that should work. Maybe that was the problem. Yeah, you see, it's not an exact science here. Yeah, so that worked. So we get 92 views here, and so yeah, so now we've hooked up MongoDB, and so now you're seeing how we have a schema in which we're actually joining together data from both SQL and from MongoDB. And the schema here is very simple. You can't see it in the schema. You also can't see it in the resolve functions, which are very simple. I'm going to take the posting out here because we don't actually use that. So this is also very simple. And sort of the complicated stuff is happening in here. But if we weren't creating any mock data, then this file would actually be pretty short and also pretty simple. So you see how you can wire together all these things to really create a very nice sort of layer on top of your database. It's sort of like a layered cake, and it works really nicely. So the last thing I want to show you is how you can actually now also call to a REST API. And I couldn't really think of a great example, and so, or I couldn't think of anything that really made sense and integrated well here. And there was also a REST API that didn't need keys. And so we're going to do something that's kind of, orthogonal to a blog, but I thought it's fun nonetheless. So we're going to use a thing called a fortune cookie API, and that's going to return us nice sentences from fortune cookies. So let's define that in the schema here. And that's going to return us a string, which is basically the fortune that you get in your fortune cookie. So if we run that, or if you save that, we go to resolvers, and so we're gonna say here for the query we had author. Now we also have get fortune cookie, and get fortune cookie doesn't actually take an argument, so we can ignore all of these, and we'll return fortune cookie.get1. And we don't have that yet, but we're going to write it in the connector in just a second. So we're going to import fortune cookie here. So we're going step by step here, and we're kind of working our way backwards. So we're going to define these down here. I'm going to define the fortune cookie. So const fortune cookie. And we have our get1 function. And that should return something from the fortune cookie API. Now we need to be able to make a call to that fortune cookie API. So I'm going to import a package that's called request promise. All right, and then I'm going to use that down here to make a request. And this is what the fortune cookie API looks like. I think it's fortune cookie API .com version 1 cookie. Okay. How do I know? It's not because the documentation is so great. It's it's trial and error, how it usually is with RESTful APIs. So what we get back is actually a response in JSON format, so we need to parse that. So REST, this should not be REST here. Shouldn't talk and code at the same time. It's kind of tricky. Right, so that returns that, and then we actually only want part of that thing. And the only part that we want is, so this will return an array with only one item, but still array, and it will have a fortune on it, and it will have a message in that fortune, and that's the thing that we want to return. So, right, okay, let's see. Okay, and we're going to export that here. Okay, so far so good. So the next thing we're going to do, actually we quickly have to install request promise. Okay, so installing. And the next thing, we'll just start and we'll see if that's working. Hopefully it won't crash this time. Okay, so I created the data again here. Let's just at the end ask for a fortune cookie as well. Right, get a fortune cookie. And what is happening? Maybe the fortune cookie API is not actually responding to our requests. That would be very unfortunate. Oh, it did. Okay, so it just took a while. So this whole request actually has to wait until this fortune cookie API returns, but it returned a very nice sentence to us. A fool in a gown is none the wiser. Let's run it again. I want to get another fortune. And, oh, grumbling makes the loaf no larger. All right, so this pretty much concludes this video. So I hope this was useful to you. And if you have any questions, let us know in the comments. Or if you find any issues with the GraphQL tools library or anything else, then I meant to say let us know in the comments, or if you find any issues with the GraphQL tools library or anything else, then head over to the Git repository and just file an issue there. All right, so that's it for today. We'll have another video out, I think, sometime soon about how to build a client-side GraphQL. And so for that, we'll be using our Apollo client, which is a sort of a more lightweight GraphQL client than Relay. So yeah, that's all right. Thanks for watching.